Rational numbers. Let's start with a definition. Rational number can be written as a fraction, and not just any fraction, a specific fraction, a over b, and a and b have to be integers, and b isn't allowed to be 0. So let's take a look at these things. A and b have to be integers, so you can't have something like pi divided by 1. That won't work because pi is not an integer. And a over b also has to have b not equal to 0. Well, that's because something divided by 0 is undefined, so that won't even be a number at all. So all the numbers that we work with, like 4, well, that's a rational number because if you can write it as a fraction a over b, and of course 4 can be written 4 over 1 or negative 4 over negative 1, both of those are integer divided by an integer, and they both are equivalent to 4. So as long as you can take the number and make it into a fraction somehow, it will be rational. So of course fractions themselves are all rational. Doesn't matter if they're positive or negative. And as we saw earlier, decimal places. Now if they end or repeat, then we have methods for changing these into, in our case it was the whole number, take away the part that doesn't repeat, divided by 90, or 21/90ths, and that can reduce to 7/30ths. And again, you have an integer divided by an integer, so this is rational. Okay, let's take a look at another type of question. So I want to locate these numbers, negative 3 over 2, 1.5, 0.4 repeating, 0.4, and negative 1 and 1/3 on a number line. So let me draw a number line. I always like to have 0 in the middle. The negatives will be on the left, positives are on the right. So there's negative 1, negative 2, negative 3, and I've already found my first number. Negative 3 is right there. Okay, negative 3 over 2 is actually easiest to think about as negative 1.5, and so there's the second number. 1.5 is in the other direction, so if this is 1 and this is 2 and 3 will be over here somewhere, 1.5 is right here, and you'll start to notice that it's actually easiest to put things on when they are decimal places. So 0.4 and 0.44, well, as long as you realize this is 0.44444444, then if half is here, it's just a little bit lower than half, so we'll put it there. And then this one's a little bit trickier. It's on this side because it's not quite as big as 0.4444. It's just 0.4 and the next digit's a bunch of zeros. So I'll just indicate it by putting it a little bit on that side. And then this last number, if you think about it as negative 1.3 repeating, so negative 1 and then a third is about right in here. So there are our numbers on a number line. And putting numbers on a number line is actually a great skill so that you can answer questions like this. Which is larger, 2/5 or 3/7? So a few different ways to do this. One way is to change them into decimal places. This is 0.4 and 3/7. Oh, that's a bit tricky. If you don't have a calculator, you'll have to do long division. If you do have a calculator, you can just punch that in and get 0.428571, and all of that is repeating. And now which one's larger? Well, 4, those are tied, 2, and this is a 0. Oh, 2's bigger. So that's one way to do it. Another way to do it is to make equivalent fractions. So if I give myself a little bit more room here, I would make equivalent fractions by making them both, say, out of 35, 7 times 5, so 3 times 5, times 7 times 7. These are really close, as you can see with the decimals, but the equivalent fractions are also bigger. Therefore, you know which one's larger. It gets a little trickier when you get some negatives in here because you have to think about what it means to be larger. So you can change this to negative 1.4444 and this to negative 1.4, but some people have a hard time figuring out which one's larger. And on a number line, larger is to the right and smaller is to the left. So negative 1, 0.44444, negative 1.4, so negative 1.4 is larger. We'll keep this video short and see you in class.